Testing.
Really are here, Madrid and Amsterdam, and we want to like have space to like
Yeah, but I was at IBM for 3.5 years, and then I
Really? Even Amsterdam.
Sandra, our major office is really new.
yeah.
No, I don't think but I did, they did not accept my paper. That's okay, they did next year.
For payments processing. So we have like a few different solutions. We have like in-person payment processing. We do like mobile.
International.
And then we're looking and currently like about to expand it a little bit more like app-based processing.
It's funny, like I was in Israel and Netherlands 3 weeks ago.
No, I'm not on the bench.
There's nothing. Here, you still see it.
Many backends are scaled right out here. Chicago's been there for so a lot of different roles open.
Testing.
You would know, I support our product hiring.
Yeah. Sometimes like on occasion we go to like
I need some stuff too.
things like that. I'm not active.
Now we get ready and just. All right, let's see what time.
Starting or just?
Okay, this is 6:15 or should we?
I
It's okay. Yeah, you still want to, yeah, eat something? Yeah.
I just need to get to the.
Yes. You to go back
I
out
went
where we
to
came from?
the other place.
Yeah, like to the other, by the other.
I can take you.
Yeah, oh,
I can guide you.
Yeah.
Do you wanna?
It was that way, right?
Yeah, I can. Yeah.
I worked.
Okay.
Yes,
Oh, you don't need to go. I thought you were gonna go. No, you're not now. Okay.
Never tried it before.
Michael.
Oh, really? Yeah, that's it. You're very smart.
Was there already this? Oh, yeah. I thought the working office was yeah, I'm just thinking the.
Oh, I didn't know. Tell me about that. So you cannot eat anything?
All right. One that's able to.
No, hired a couple.
Even when I go to like the.
Oh, yeah.
I can have a time. If you eat deep dish now, all these
We have a lot of, you ever talk to the.
So I heard from him that you're from Odessa. Wow, amazing. I was there. Yeah, I traveled to Ukraine. And then I visited Odessa and Kyiv. And so Ukraine too. Although Odessa, I think I flew. That's right. That was 2 years ago before the COVID.
Guys, obviously, 5 years when I left.
No.
8 years ago. And it went through a lot of changes, architecturally, but it always looked beautiful.
Yeah.
When you were visiting, last time. It's beautiful city.
It is beautiful, yeah. Right by the sea.
It's small, it's
Yeah, by the water, yeah.
right.
Very
It's,
nice.
it's a 1 million
Very nice.
made a lot of changes. Last time. When you were there, it was like the same kind of architectural. It's not really changed. I was reasonable there. I finished out
It's gonna be really
lots of changes. A lot of changes. But all the preserved architectural styles are the same. It's always like built like French architecture. But it's 200 years ago. It's about 200 years old. Back then, the center of the city. Yeah, kind of almost 200 years. Buildings. Mostly not very high rise.
Yeah, that's right.
But they're pretty.
Yeah, from what I remember, there's just.
The suburbs are high risers that kind of like not like downtown with apartments, maybe 7, 8 stories. Most people 16 stories. There's more than one suburb.
Yeah.
That's the main concern is obviously the beach during the summertime. There's always a lot of things to do. A lot of people tweeted one of the vacation spot, kind of beach spot for Ukraine.
Perfect. Sounds good. Yeah, sounds good, yeah. Okay, and I'll check with Jakub. They were just saying that we haven't seen more people coming in, so hopefully there are online people too. Yeah, I'm sure there are online people. Have you noticed
One or
people
two.
asking that question?
Yeah. Maybe we start now so people will stay.
We can start too. Yeah, this is like 6:20, so
Okay.
yeah, that might be good. Or like in a minute or so.
I just, on my way here, I figure out the ticket machines for the trains are in Polish, which made me feel like at home.
Yeah, that's right. Yes, some things are still very old-fashioned around here.
So I just need a second.
Sure. Yeah, when you're ready.
I'm still good on the phone. I'm still good on the phone. When it becomes like, it's like, all right.
I'm just going to give a background of who the audience is and kind of what we're doing here. Yeah. Specifically our background.
All right. I think when you are ready, we can start. So.
I think we can set up.
Your audio is here, right?
Audio is here. Maybe.
Oh yeah, the audio should probably be closer, right?
Are we limited on how to do this? Yeah, so it's like
Okay, we can move this.
do what's at your convenience.
You okay, right? Does the audio need to be higher up? Is this way it can capture?
It's going by one. We're gonna have to go away from it.
Actually, I should ask you, would you like to make any announcements?
Yeah, I have a quick just who we are.
Okay, yeah, for me, I'm just going to do housekeeping things. And then after that,
Yeah, it's not the best, I will say.
that might
help. It might help a little bit.
Okay, thank you.
Yeah, thanks.
Does it go into your pickup?
It's
Pick up.
okay.
This is very high sensitive.
Okay.
Gotcha.
To say that, I'm going to talk about that first and just go straight to the slide and do the next one. Say a few words.
Yeah. Cool. Cool. Sounds good. Sounds good.
I actually should ask him.
It's up to you. Let's make it fun. So CH is English pronunciation, but in Polish and Eastern European CH is H and C is silent. So it's like Mach and then V. So when I was working in Holland, yes, when I was pretty close. When I was working in Holland, all my Dutch friends, whenever I was on the phone with my Polish colleagues, they say like, "Man, I thought you were having this trouble." Yes, that's it's close enough.
Maybe I'll just speak.
It's like similar to Mr.
Okay, so if you're ready, I'm going to start in a minute or so. Okay, all good? I guess our camera is all good? Okay, all right, I'm gonna start. So welcome everybody to CJUP. Right now, this one is our third in-person for this year, and it's really nice to see a number of you here. And of course, we want to thank Admin again for hosting us. This is really nice, so thank you. And then of course for Jakub to have come all the way from Poland. So thank you so much, and our helper.
All the way from the West Coast.
West Coast, yeah, that's right. Well, the last one. But
I'm on my way back home.
Yeah. Okay. So today we have Jakub Marchwicki.
Marchwicki is fine.
Marchwicki. Okay. Presenting from Gdansk, Poland. So let me kind of switch in here. Okay. Go over here.
When you were on Latvia, have you tried Kvass?
I'm sorry.
Have you tried Kvass when you was on build stuff?
Build stuff?
You've been on build
Yeah,
stuff.
I've been on build
You've
stuff.
tried Kvass or not? Kvass.
No.
No,
Yes. No, I have not yet.
No,
Okay, thank you. Okay, so first of all, before we start, I want to also again point out that CJOG, we continue to stand with Ukraine. So this is something that is all, kind of that we do for all the jugs around the world. And then today too, we're gonna have a raffle, 2 raffles actually of JetBrains complimentary licenses. And but then the thing is, if you won within the past 9 months, then you are ineligible. But I don't think anybody in here have won within the past 9 months, so you're all eligible to enter the drawing, and that will be done towards the end of after the presentation and after the Q&A. Okay, and go. This thing doesn't work today. Okay, and just some housekeeping items. We have our Chicago Tech Slack. This one is actually run by Cedric, who used to be helping out with CJUG too. So he's keeping this tech stack running, and there are folks from all over the world who are on this Slack. If you haven't already joined yet, there's just a nice community. And then we have folks from other places in the world too. So it's about 11,000 subscribers right now. And we also have our current Java news from Freddie Gimei, who was the CJUG president previously. He's still running the Java Off Heap podcast. So if you're interested, follow him on javaoffheap.com. And also Bob Pollan, too, is also speaking there, and also Michael Minella, who is now the Spring Batch, or not just Spring Batch, but he was the Spring Batch leader, and now he's the director of the Spring engineering team. And also, make sure you join us on meetup.com if you haven't already done so. Okay, sorry, this thing doesn't work. Okay, please follow us on Twitter if you haven't already done so. It's @CJUG. Okay. And then we also have a Discord chat channel, so that's kind of helped to facilitate communication. So please join us on our Discord if you like. Okay. And some community info. We are a community partner of this group called defitjobs.us, and that's an online community, a global place where you can, like, if you're seeking for jobs, especially, they have job listings there too. And upcoming events, actually, we are still planning. Actually, I meant to say planning in December is potentially we have somebody from Event Store Database coming from Boston. Either he will be doing it remotely, or we're just going to find a place for him to come. So, but stay tuned. And if you're interested in speaking at CJUG, please submit your proposals to present at cjug.org. And for job seekers and recruiters, please join our CJUG group on LinkedIn, and this is the link and also the QR code. And by the way, I'll be sharing this slide deck with you, so then you don't need to copy anything in here. Okay, now the next thing is logistics. Of course, we have food and a beverage here. Thank you so much again to add in. Otherwise, we also need to know the bathrooms. That's important. Then that will be like when you walk into this facility before you enter into the locked area. So in other words, if you need to use the bathroom, you need to go outside and make sure somebody will open the door for you again. So thank you, folks here, to help us. Food and drinks are all here. And then the next section is, also, if you do not want your pictures to, yourself to be photographed because we may be posting them on Twitter or social media, please let me know. That way we make sure we, don't violate your privacy too. So let us know. And here, we want to thank our gold sponsor, JFrog. They're not here today, but otherwise they've been really a very big supporter of our group. Oh wait, not yet. We want to also recognize again Adyen for hosting us, and this is our event sponsor for today. And I think you have a few words to share with us.
For sure.
Okay, here we go.
Hello, everyone. My name is Michael Stroh. I'm a technical recruiter here at Audion. I support the engineering, specifically the Java. And we are a global, fintech company founded in Amsterdam. We have about 2,500 employees officially. We really focus on payments, but we also do issuing. We actually just got our banking license, so we do banking and other areas as well. And we work with merchants such as Microsoft, Uber, Airbnb, Netflix, and so many other companies. The list goes on and on. So Chicago is really going to become our tech hub of North America. It's going to be growing more than any other of our other offices in the entire world. It's a really exciting time to join. Specifically on the back-end side, what really separates us from other companies is that we have one platform for all of our customers, not multiple platforms, and we're the only company with one platform from scratch, which really sets us apart. In terms of our backend teams right now, we're not only growing, but we're scaling. We very much so are looking to hire, so if you're interested, please contact me or see me after. But we have, a scalability team. So as I said, we're, a payments processing team. We have hundreds of thousands of transactions every single second of every day. I shouldn't say every second, but every day. So that's one of the teams. Another is an in-person payment, so an IPP team. So essentially, when you go to the likes of, I don't know, a Starbucks, let's say, and you use your debit card or your credit card, we're very much on the back end. And although we might not be customer facing and you might not see us, we're on the back end. And I guarantee you we have done the back end work of some of your transactions. And last but not least, but we're merchant facing. Like I said, that's another team on the back end side. We support the likes of the Ubers and the Microsofts of the world. So I always like to ask my hiring managers, what's something to get really excited about this role or this company? And there's two things. This is the beginning of a long journey. We're a 2,500 global company, and we really want people to join and really grow out this entire office. So that's the first one, is get really excited about that. And number two is there's so much complex problems that these engineers are working on. If you're somebody that loves complex work, this is a great opportunity for you. We are very, very Java focused, and I believe all of you are as well. So exciting times, and welcome everybody.
Thank you.
Thank you.
Thank you. Okay, so now let me go to the next one, which is we'd like to kind of share with you the Friends of CJUG, and in fact, it's a worldwide Java community, but I want to give a shout out to these JUGs, Atlanta JUG, Boston Java users. They become like Boston Java user ACM chapter now of New England. And then Garden State JUG in New Jersey, Kansas City JUG in Missouri, New York Java SIG, that's the oldest Java users group in the US, and Pittsburgh JUG. So these are like good friends of us, and there are lots of speakers too, and they're also running a lot of meetups too. They continue to run it during the COVID. So we like to highlight those, and they are still doing, some of them are still doing online meetups. So please kind of look them up too, and they have really good speakers there. And then, last but not least here, the intro slide deck is to introduce our guest speaker from Hazelcast, Jakub Marchwicki. Okay.
I should make it a quiz or something.
Yeah. So a quick intro. Jakub is the lead software engineer at Hazelcast, and he's from Gdańsk, Poland. And he's also a well-known conference speaker. He's active with the JUG community. He's also a JUG leader. And he has 20 years of hands-on commercial coding experience that covers a lot of languages and frameworks. And he has had roles as architect, programmer, manager, technical trainer, and tech lead. So with that, I will turn the microphone on for you. Here's Jakub.
I'm flattered.
Yeah, okay.
Thank you.
Thank you.
That's,
So you can
I wonder,
Thank you.
do I need this or I don't need that?
Oh yeah, that's right. You don't
Do I need it?
like, you have your clip.
Okay.
Okay.
So I need it. Just bear with me for a second.
I forgot to mention too, we have some T-shirts that are from Red Hat when they did the Quarkus World Tour. In fact, they were sitting in my house, and I forgot to bring them at the last in person. So I brought them here. So if you like some T-shirts, these are older, but they're a Quarkus World Tour from 2021. So feel free. There are two sizes too. Before you go. So.
It's gonna be fun. I'll probably bring something. Okay. So you said you're a Java shop in Ireland, and this is Java group, so there'll be a Java-oriented testing talk. Who's practicing microservices? A couple of years ago, when I asked about microservices, people were like excited. Yeah, I see things changed. I truly wonder why. That's good. As Mary said, I'm from Hazelcast. I work remotely for the last couple of years. Hazelcast is an in-memory computing platform, but this talk will not be about Hazelcast. I work remotely. That's where Kat is joining every remote conference call. You probably know that feeling from COVID times and pre-COVID times. Yeah. So to give you a little bit of context, what is Hazelcast? Hazelcast is a fairly complex platform that lets you pull in data, keep it in a cache or near cache, and then process it. Think about stored procedures, but on Redis. So you have everything in the memory, and you can process it as a stored procedure. Very complex piece of software. But in the context of what I'm telling you, I work in Hazelcast in a cloud team. So we are taking this product to the cloud as a managed service. And that's what I focus on, and that's where it's coming, where I'm coming from. So we, a couple of weeks ago, launched a new version where you can in seconds, get yourself a platform, which is not easy to install and operate. And it's all built on microservices stack. We got a couple of dozen services. That's all distributed system, managing distributed system. How complex can be that? And what I'll be sharing today is a couple of thoughts, ideas, and remarks, how we are testing that so that it's becoming, I hope, fairly reliable, or at least it's getting better and better. So whenever I'll stand here. Okay. So whenever you get into testing, you have those 3 layers of testing: unit testing, integration testing, and UI testing. And as all that it is, can I swear or I shouldn't? It's not fairly relevant, or otherwise speaking, it's just bullshit. Because there are a couple of things that this triangle doesn't include. Because if you're running a modern software, especially as services, especially in the cloud, so what about like testing the deployments? Because our pipelines for deploying are a fairly complex piece of software. And it's, not everybody is testing that. What about infrastructure? People either do manually infrastructure, which is just bad, or they automate it through some Terraform or other scripts. Is it tested? Probably not, or not everybody is testing that. And this is also part of our application. What about cloud? So we are deploying to the cloud. We are dependent on a bunch of AWS or Google Cloud services. Are we testing that? Or are we just assuming, it's part of our infrastructure, it always works, and it never changes? Well, that's not true. So this triangle is not entirely relevant. And then we get more. When we talk about just microservices or just individual services that we are running, there's a couple of questions that I usually ponder about. So if that's our archetype microservice, imagine that's a classic, classic microservice. You got a piece of your code which is running together with a framework, and it talks to a database, and it consumes some API or exposes some API, and there's a bunch of monitorings. So if you say, I'm testing that, usually people say, I'm testing my code. I'm unit testing that or whatever, testing that, just testing. And what about all the rest? Now, this is our logic, and what about the integration with the framework itself, all the HTTP traffic, all the marshalling, unmarshalling, I/O, and so on, and so on. When it comes to microservices, it's like, I would like to get an answer from my test. Will my service even start? I know how often you had this situation that you build a piece of software or you amended a piece of software in your service, then you build it and you're trying to ship it, and it didn't even start because your testing was so much different from, for example, runtime configuration. So even if I try to starting it, then I have to answer my questions. Can I deploy it? If I deploy it to an environment, will it break something else or it won't? Have you ever tried to answer it yourself? Or will it deploy? Because the fact that the service has started in some context doesn't mean it's deployable. It can have some external dependencies which are not correctly configured on this particular environment. Or finally, will this service run? Even though it starts, it deploys, it starts, will it behave properly in runtime? These are questions that my unit test wants answered. And these are questions that I would like to get answered at some point. And this presentation will be pretty much about it. So, I'm kind of nervous. Let's decouple it one by one. And I don't want to switch between presentation and the code, so I'll walk through that, and then we'll look at some code examples. So that's convenient for you. So no walking. Testing my code together with a framework. This is you're a Java developer. So what framework are you using? Spring. Micronaut. Okay. One way or another. Some examples will be on Spring, but that's pretty much still the same, slapping a few annotations here and there. So testing code with my framework. One of the things is, or I will play it as an example. Imagine we have this fairly sophisticated piece of JSON message that is being transmitted over the wire. No funky stuff in here, UID field. We would like to test it. So this is a payload that my service will consume or will be sent to. I would like to know if, given that text representation of my data, will my application consume it correctly? So will I pretty much marshal it into some object representation? I have my code. So I'll build myself a test for that. So if you know Spring or any, that's not even Spring. I have a text representation. I have some object mapping library in this type JSON, and I test it one way or another. So I have my text representation, see if it is unmarshaled, and then other way around. Very simple test. Surprisingly, it works. But I missed the slide. Yes, I missed the slide. Yes, I have my object. Damn it! I spoiled the joke. So it works. What I did here is I remember. I'll do this like this. There is this funny thing on Google Slides. Laser. Okay. So what I had here is I outwired object mapper and have a JSON test annotation, which is Spring-based. Somebody might say, hey, you're just running a whole container or part of a container to inject object mapper, which you can initialize with new, right? Somebody can argue this will be faster. Yes, this will be faster, but this will fail. You've seen that. Why this will fail? Because most of the frameworks, and that's the part where the code is integrated with the framework, most of the frameworks, even Micronaut, Spring, whatever, comes with a pre-configured mapping, pre-configured serializer. Object mapper has a lot of configuration. This assumes the default. Spring's defaults are different. And Spring's defaults, for example, know how to handle timestamps in any text representation and convert it to a zone date or date, where vanilla object mapper doesn't really like it. Vanilla object mapper, as you can see, I have some unknown field here, which is not represented in my bean, in my object representation. Vanilla object mapper is failing when it has unknown field, whereas Spring has attributes, don't fail when you have an unknown field. That's why I try to get my framework together with my code. Not every time, but I want to have the safety net that when I run it together with a framework, the behavior will not be different. That's not the only one. So if my JSON representation is not a camel case, but a snake case, because some hipster Python developer is sending me something, this will always also fail, because object mapper by default wants camel case. And I can configure that differently. But again, I have a test that is failing that is so much different from my from my actual business thoughts, from my actual framework. That's why, yeah, this one, right? That's why I want to have a little, at least some tests, which are testing, is my framework applied correctly to my code? Or are my tests testing my own imaginary application, or really the application I'm running on production? So I call it basic integration tests. So what I'm trying to get there is basic framework integration, like object mapper, like configurations, like configuration properties from a file, everything that I assume is just working, and it's working through some framework magic. Configuration are write properly, our object serializer does the application works with those dependencies, like external dependencies, like database and so on, abstracted. That's the first step. Some people argue, and as I already said, whenever they hear running a test with a framework, they say, "Oh, that's going to be slow." So why are we talking even about time? How long are your pipeline is running? When you have your project, or like a subset of the project, module, microservice, the complete build, Maven verify, Maven clean verify, complete build with all the tasks, how long does it take? 3 minutes? 30. 30. Whoa.
Sometimes it depends.
I know, it only depends. And so who's running shorter than a minute? Shorter than 5 minutes? 10 minutes? So the problem with time is, what are we doing when we're waiting for the tests to finish? So there is this concept, which is not coming from the computer science even, that if a system responds in less than a fraction of a second, it's 100 milliseconds, it's perceived by a user that it's reacting instantaneously. If it's about a second, then the user sees that, okay, something is happening, but he's still in the same context or in the same flow. The thoughts are uninterrupted. And then when whatever takes more than 10 seconds, people lose attention. Whenever my test or my build is running more than half a second, I kind of subconsciously open a browser and land on different pages, totally forgetting that I have to do something. These are not numbers that I've invented. This is coming from mid-60s. There is this paper by George Miller, which is called Response Times to 3 Important Limits. That's actually measured human perception in terms of keeping an uninterrupted flow. So imagine now your test is running half a minute, your build is running half an hour. I did a comment when I was using Gradle, that when I was running a complete build suite, so test and integration test and black box test, my console was telling me that it finished. Otherwise, I realized after 2 hours that I was building something because it took so long. That's why we're trying to get tests shorter and shorter. And I will argue, and I will show you later in examples, that running tasks together with a framework doesn't mean to be slow. In Spring context, running a Spring context together with a subset of your application, like a few classes that you're really interested in, takes less time than mocking them. Mockito, especially when you use annotation, takes more time than running Spring. I'll prove it to you later on. But back to tests. Even if we test our code together with a framework, we have a fairly confidence that at least the basic configuration really works. But then there is everything outside my word. So my application is exposing some HTTP endpoints. So what I like to test and verify is that when I expose an endpoint and say, hey, you can send me this JSON, I want to make sure that when I iterate on my application, it hasn't changed. I still can accept the same payload. I still can accept the same, I'm still accepting the same URLs. Because the more declarative is your framework, the easier to, I don't know, shift all the URLs by, a prefix just globally, or change authentication to require some new header or whatever, and it just stopped working. And the same with other services. Like my other services are something that I'm calling out. So I want to make sure that during, working on my code, I haven't changed something accidentally, and now I'm trying to call different URL, or I'm marshalling the message in a completely different way. So another example. First of all, what I employ is obviously WireMock. So I try to pretend that there is a server that I'll be consuming. So I say, oh yeah, my laser. I have a WireMock test. I hope everybody knows WireMock. I fake an HTTP server. Well, I don't fake. Underneath it's a real HTTP server. So I have a server which I instrument saying, hey, when you get this request, just answer with this JSON. And then I have my own code which is trying to get all the classes, and it verifies that when some endpoint returns some JSON, it can be a JSON file. I can just instrument the file one by one. This request is pretty, this response is pretty big, so I didn't want to clutter this. I can verify in a fairly black box way that yes, I got an answer that I was expecting. So I'm not only testing a piece of my code, but I'm also testing how this code behaves when it reaches out to the wire. So it reaches out to the I/O. I can do the same with the other way around. So this is a pact example. Who knows pact as a tooling, or who knows contract testing? I'm so sure. Oh, okay. So the idea of the idea of contract testing. So the idea of contract testing is that if you know, just shout because I'll start explaining, and it will be. The idea of contract testing is that my application exposes something, gives some data back, creates a response, and I would like to make sure that this response doesn't change, or I change it consciously, that I do not break compatibility. So contract testing is about working both ways. So in this example, I'm saying, and this, no batteries. So in this example, I'm saying, hey, I will be sending a message, which will land on this path, have this this URL. It will be a post with this headers and a piece of body. And this is more of a, not an assertion, but expectation that whenever this piece of code will be run, whatever goes out into the wire, so whatever happens, this will stay valid. So this URL, this URL will be called with this headers with this body. So whenever I change something, this test is a kind of a validation that I haven't. This test is a kind of validation that if somebody sends this this payload, my application will still behave correctly. And you can always also do it the other way around. So you can build up an expectation that whenever I whenever I invoke this this URL, my application invokes this URL. It can be a third-party service or some other microservice in our organization. This will still hold. So what we can do with that is, on one hand, I am verifying that my application is adhere to expectations of other collaborators in my environment, in my application landscape, and also I am sending out my expectations. So if you start using that, you can get to a point that you can't really break compatibility on your endpoints because your test will start failing, and that's what we are trying to do. The downside is, yeah, it will take time because we have to build up application server, well, not application, HTTP server. We actually have to send something over the wire. And then on the similar level of the external dependencies which we are working on, it might not only be a HTTP endpoint. It might not only be a service. It might be a cache. It might be a file system. It might be S3 bucket. It might be something else which is not necessarily a database that we would like to test as well. So in this example, I'm pulling a Hazelcast instance, which was our cache at that moment, and pretty much checking if I put something into the cache. So if I create myself 2 instances of a cache and I put something in one way, I will also receive it in the other way, so that my application can really work with the cache, and my entities or my DTOs can really be handled by the cache. Because, for example, cache comes with different flavors, and in terms of Hazelcast, there's an expectation that the objects will be serializable because that's a distributed system. So I have to make sure that whatever I'm trying to put into the cache, like a tournament in this case, will land there and will be operating. And I call it advanced integration testing. Why it's advanced? Because it takes an order of magnitude more time than just running my application together with a framework. It takes time because it goes out to the I/O. So it's slower and slower and slower. But what I'm trying to verify is the integration of my I/O operation correct? So I can save to database, or I send over the wire to one application or the other. I can try validating if API I am providing is still correct. And for example, if I'm using a message broker or Kafka or RabbitMQ, that's a point where I can verify if, for example, serialization of my messaging really works with the broker. Because I've seen a lot of places, even in my own projects, that everything worked fine until I tried to submit a message to Kafka. Because it didn't work because I have some weird, funky serialization turned on Kafka side, not in my application, or the other way around. So this is what I'm trying to validate. I said it takes time, and it can take a lot of time. And there are some subtleties that I would like to ask you for. So if we have, that's a more quiz, there's no prices. Prices are for free. So if I have this kind of test, it's a very simple test. Everybody knows what's happening here. We are just running a Spring Boot context application. We are running. And I'm running it 20 times. So I'm doing like repeat the same in my test suite, in my Maven Gradle test. I'm repeating the same test 20 times. How many times will Spring context will be initialized? There are just 2 proposals, 1 or 20. 1. There's one answer 1. Other calls? 20. Okay. It will be just 1. It will be just 1, ponieważ Spring, sorry. It will be just 1 because Spring is smart enough to figure out that this application didn't change. My context stays the same. My context is cached. If you go deeply into Spring Framework, in the test context, there is a thread local which holds the application context. And Spring verifies, oh, nothing has changed. I can reuse exactly the same context and run it again and run it again. That's why when you start using Spring integration testing, you don't really get a huge performance kick because everything is cached and Spring thinks about that. But what if we extend it? You know, test containers? Test containers just pull up the Docker image for application. So I have a very similar application, but this application is dependent on the test containers or on the MySQL. So I have a test container annotation here, and I am pulling it MySQL. So if I run it 20 times, how many times MySQL will be pulled? 1 or 20? 20. Other takers? Sorry? It's
The container.
yes. Well, the answer is correct, but the reasoning is not correct. It will be around 20 times. It will be around 20 times. Yes, because it's a container, but on the other hand, once I run the container, I can keep reusing that, right? It can be there. The test containers lifecycle, by default, clears everything out and starts again. That's the default behavior of test containers. We can change it. We can configure it. We can declaratively do it differently. But by default, the behavior is completely different. So once we get into this, world of running integration tests together with stuff around, with some servers, with some HTTP or with a database or anything else, we need to better understand what's under the hood, because there are a lot of catches that can really make us trouble. My best horror story is that in one of the projects, we had to test together with MySQL container with the database. It was verifying that if we remove the data from the database, the application will respond with 404. And to do this test, for every test that was creating some data and checking if behavior is correct when the data was there, the data was removed, and then tried again. So for 40 tests, I had 80 containers starting up and starting down, starting up and starting down. Each container, MySQL is fast in the containers. It's just 30 seconds times 80. And people were upset that the build is slow. So just by figuring out what is happening and making the container static, in this case, and intersecting into the life cycle of the container, we just give it order of magnitude speed boost on just by that. So we have to be cautious. What's going on? What's going on? So again, back to tests. We get to a point that yes, we have tested the framework, the application stuff around, and we get to a point of we would like to have a better view how this application behaves as a whole. Because if you follow, for example, 12 factors, the application should have all the dependencies should be declarable through environment variables. That's what I'm trying to stick to when I'm running my services. So if that's the case, I would like to test a situation where my code is bundled in a way that will go to production. For me, it's a Docker container, so it's fairly easy. And run it as if it was running on production, and then see what happens. What I'm missing, or what I have to configure, or what I missed in the configuration, and so on. So I'm trying to package my whole application as a Docker container, and run a few tests. But before we get there, there is possible step in between. So if you're exploring test containers quite a lot, there is a bunch of examples that show you. There's a lot of code here going on. That suggests you take your application, run it as a test container, so run it as a Spring Boot test environment, and have everything together and see how it's working. So you get a lot of plumbing here, where actually what this test does is checking if my ping endpoint responds pong. Not much, lots of plumbing, but not much. So if my application, and if we are running, for example, on Kubernetes, there's a bunch of guarantees that our application must provide for successfully to run. Health checks, liveness check, environment variables, other stuff. So this is an opportunity for us to test it. So we are running everything as if it was complete application with all the dependencies. We are not mocking with anything. And we can test, for example, if we have this ping pong endpoint, if that's the case, or if our Prometheus endpoints, metrics endpoints are still exposing data. Quite a common problem. Couple of springs ago, so a couple of Spring framework versions, there was a bug that when you upgraded from Spring, I think, when you upgraded a patch version of Spring, all metrics disappeared. There was a bug. And then they changed again a couple of versions later that the metrics names became different for, that was like announced as a breaking change, but not everybody noticed, who reads notes. And this is an opportunity for us to test it. So if we are relying on some metrics and we would like to make sure that these metrics are still produced, we can just run it all together and show it. There is a downside of this approach, because as I am running this as a Spring test, I can fiddle in whatever configuration I have, because I can still pretend that something is different. So I can sneak in a different configuration, supply a different type of a bean. So it appears that I'm not really testing what's on my production. I still can fiddle with the configuration of my app. That's a downside. I've seen in our project, for example, when people are exposing an application to the outside world, one of the things is what they don't want to do is like, we don't want it to be publicly available. We'll put some security on that. So the moment they put some security on that, like a JOG token or whatever, it's become very complex to test it, because you have to get a valid token. And to get a valid token, you probably either have to mock a different service or somehow assemble that token. And your code is getting very complex. So what I've seen in one of the projects, for all the tests that were testing the web layer, the developers were sneaking in a different configuration that overwritten the security configuration and just tested it without security. They tested the controllers, it was fine, but they didn't really test the security. We figured it out one day when it appeared that after upgrading the Spring framework, the Spring security changed, and we haven't noticed that, so our endpoints just became insecure. It's good that we caught it early on, because it was quite funny. What you can also do is you can, and that's also provided by Docker, by Test Containers. Test Containers has a funky class, which is called Docker Compose Container. And I can define a Docker Compose file, which defines my whole environment, and say, hey, just run it. And then we can even test if our service is behaving correctly when it's highly available. So if we are running 2 instances in parallel, does it really work? That's one of the problems that people have when they, for example, consuming some messages. If we have 2 services that are consuming some Kafka topic or some queue, there can get a funky stuff. For example, queue might be exclusive and the other service won't work, so we have to configure it differently. Or the topic will be configured differently, and we get both instances getting the same message. This is a time where we can test for this more complex situations. I call them black box tests because I try to get it as black box as possible. Assemble everything all together. Integrate all the layers of the application together with queues, database, with a configuration that is on production, By the way, I have only one configuration for my applications. I don't have application-test, application-environment. I consider it personally a bad pattern. I can verify all the readiness verification, all the readiness checks, logs, and metrics, and I try to test as close to the production environment as possible. Someone can say, hey, it's not possible because you're running on Kubernetes or you're running it in the cloud and so on and so forth. But the Docker container is quite a neat abstraction that once I run it locally as a Docker container with all the environment variables and all the stuff, there's a fairly big chance that when I deploy it as a, I don't know, Elastic Beanstalk to AWS, it will behave exactly the same. And that's what I'm looking for. So the idea is that once all my tests run through, I can pretty much confidently deploy. Ideally, run the pipeline, go prepare a coffee, and be sure that when I get back, my ops genie won't be shouting at me that something is going wrong. But with the black box test, as everything is considered inside inside the black box, we can go a step further. Who is having like some business analysts or product owners on the project who are willing to understand like what test cases or what behavior we are testing. Some developers invented something called Cucumber or fixtures, like the higher level language for behavior-driven design. The intention was business people will start writing that. That never happened. But on the other hand, the business people are also eager to get some meaningful information what is being tested, like what use cases, what situations are being verified. So if we have our application run as a whole, we can try doing that. So we can try to prepare some features and start defining the scenarios, what's going on. Personally, that helped me once, literally once, when we got to a point of a testing billing, not a billing framework, but a billing part of our application, because that required a severe input from business people, because they knew all this situation that if I send 100 of messages of this type and then I will send something over WhatsApp, but will never get a response. That was kind of a Twilio application. What's expected behavior? Similarly, if you have in payments, that there are these higher level use cases that, for example, if my payment fails a couple of times, I have a different response, or my system should behave differently if it's just failing once. So, and this requires an input from the business people. The input can be, hey, come on, sit with me and we'll just code it. I know such business owners who enjoy that. But not everybody. So if we can find a way to communicate or to give them automatically give them output what has been tested, that's sometimes very helpful. So before I jump into the examples, more sum up why at least I consider it is so important. So if we have a certain criteria for our tests, and for me the important criteria is that how fast it runs. Because I want, like, I don't know if you practice that, but that's my favorite thing. Whenever I'm in IntelliJ, I would like to go to a test folder and run all the tests all together, always. And that's my shortcut. If I go in IntelliJ, Control F10, all tests should be run. And it should be fast. It's just unit, but it gives me a nice iteration, nicely interactive way that, and I'm changing something, I'm kind of have a better visibility of how things are doing. That's exactly what IntelliJ is doing when it runs compiler. If your code doesn't compile elsewhere, it will still shout about it. I want the same behavior about my test. To have it, my test has to be fast. And then I'm looking into a way to modify the context of my application, how my application is running. Why? Because sometimes I want to introduce a fake class, sometimes I would like to mock something. So this is important to me. But at the same time, the more modification I can be, that can impact reliability of my testing. I don't know if you have a situation that you had a test running, everything was green, then you remove the body of the services on the test, and the test will still green. Yep, that's the reliability part. So if you have a unit testing formatting, that can be very fast, or they should be very fast. I should be able to run all of them all at once. That's what I do. And you can do whatever with the tests. You can fake it till you make it, sometimes in a good way, sometimes in a bad way. That's why I consider this test totally unreliable. It can tell me in a very tiny subset that it's okay, but they don't give you they never give a general overview. So I have this next level, which is integration test with mocks. So I pull out the framework, I mock things out or fake things out in there. Let's get slightly slower. I can't do anything. I can do as much as I've designed in my application. So if my service is designed that it can take 2 parameters as a constructor, and that defines its behavior, I still have to figure out those parameters. I can't just slap nulls everywhere. But I still consider that not really reliable. I can do a lot in test, therefore I can also fake a lot in the test. And then, Jesus, what happened? I run my integration test with containers. That's getting slower and slower and slower. And I still can modify the context, but I start considering it a fairly reliable test. Meaning, if it passes, then I know that my migration on the database is not failing. Then I know that my communication with the outside world is still working as I have expected. You might say, well, hey, if you have a lot of those tests, it's very slow. I don't have a lot of those tests. I have 1 or 2 per service, where I pretty much combine or assemble everything together and just run it. And then last but not least, black box. Last thing that you can say about it is that it's fast. If you try to run WireMock with MySQL with some queuing application, that's 2 minutes for granted to start. But when it passes, you have a fair reliability that when you deploy that, you won't be surprised by some stupid mistake. And you still can impact the context. You can still change the context. You can still change the context as much as you've designed for that. So if you have some environment variables that change one database to another, you can still do it in the test containers through some context modification. And then you can get to this blue ocean of testing on production, which is not really testing on production, it's experimenting on production. And once you get this this trust that your application really works, you can go and fiddle with like traces, metrics, chaos engineering, or feature toggles, because everything that was between just works. If you ask whether you can get successfully, well, in the Hazelcast Cloud, we get from 6 months release cadence to daily releases in less than half a year. So we had a 6-month feature branches, which were being merged and deployed and tested, and damn, it was a mess, to pretty much continuous delivery, which we do not continuously deliver because our QA engineers are saying, hey, that's too fast. So we slow down a bit. But you can get this path, and this is purely coupled to the way you pretty much believe your tests are successful and fast. So that's the presentation side. Do you have any questions? And I can jump to actually showing you some code examples if you want, or you just want to shout and prove me wrong. It's all the presentation is available online, and also the samples that I'll be showing from one of the trainings that I've been given in the past. So do you have any questions while I figure out how to change any questions?
I didn't understand the difference between the warm example, which we are familiar with, we use warm for testing.
Yes.
And the other one,
Okay. So let me show it by because yeah, that's kind of an abstract term which
it's like a standard annotation.
okay. So I will use contract. So there are two. I'm looking for a diagram that just that explain it, and it's coming from a Spring. Yeah, I can use this. So conceptually, the contract testings are about separating providing side, so that part of a collaboration that is providing a response, and consumer who is consuming this response. We, as they are, let's say, two different services designed by and implemented by two different teams and so on, we don't really want to run them together. That can be payment provider abstraction, there can be merchant abstraction. Two different teams. We don't run or try to run in our tests external code, but we still want to have a certain collaboration between those two, kind of defining how this should be made. So there is this concept of a contract, which we can get in between. Contract is a textual representation of what we'll be sending over the wire, which will be used to mock request and mock response on both sides. So my provider will not be mocking the actual request, but will be using a contract definition to generate the request. And the other way around, my consumer will not be pretending that it knows what will be the answer. It will use the answer exactly from the contract to see if it's working correctly. On the code level, it looks like this. That there are two flavors of this. There is a tool called Spring Cloud Contracts, which is one implementation of contract-based testing, and there is a Pact. Pact is the second one. Spring is very Spring Java oriented. It can work with other languages, but it's like putting your trousers over the head. Not very helpful or not very intuitive. Pact is polyglot by design, so you can combine JavaScript application with Python application with Java application, and it's all work together. Conceptually, it's it's worked always the same way. So you define a contract. This is a Spring contract. I think I have also a Pact contract somewhere, but that's not the most important at the moment. So you define a contract. Your contract, an HTTP contract, has two parts. It said what you're sending and what will be the response. And this is done outside of the actual code. Two teams, two guys, two people start to collaborate, saying, I will send you this GET request to this URL, and I would like you to answer 200 with this kind of body and this kind of headers. This is just a contract. And then, based on this contract, depending on the tool we are using, you can generate a stub for one part and a client mock for the other, where the content of the request will not be something that you will handcraft. So it will be your imaginary vision how the response would look like. It will be actually taken from this response, which is another file which you can put into the repository. So this is a very contract first approach. Pact has a slightly different approach. which is more of a consumer-driven contract. So we have a consumer that defines that I will call this URL, and I'm expecting this URL will provide this kind of guarantees. Let me show it on the example. So I have a packed contract test where I'm saying I'm defining a contract now that a customer exists. So upon receiving something that's kind of textual description, I'll hit this path with this method, and I'm expecting a response 200 with this kind of body, and I can get multiple paths for different methods in the same test. And then in my test, I'm running a client trying to fetch customer by ID. Pact will generate the response based on what I've defined here, and let me validate my code. The advantage of the pact, or the tooling that comes with pact, is a pact broker. So we can define also, which I don't have it here, but we can define also that this contract and this expectation will be recorded on the server side, and then the provider of that can go to the packet broker and say, hey, give me all the contracts, and then run the expectations against its own code base to see whether the contract still holds, whether during to some changes they have broken configuration. But it's a kind of double, I would say, like the sword with two edges, yeah. Because the consumer can pretty much break somebody's own test, because the consumer can set up unrealistic expectations that still are not implemented, and that will fail the consumer build. So that requires some investigation. So that's the pact. That requires some consciousness. Does it answer your? So in a couple of projects we are using quite effectively contract testing, mostly to be able to say that we're staying backwards compatible, or we are consciously breaking compatibility when it comes to breaking compatibility. Okay. Any other questions about the presentation, or? Okay. So two more examples that I wanted to show you. This is a subset of one of our services, of one of our modules in the Hazelcast. I just, this is not super confidential, so I can show it you. This is quite obvious. We are using an external application called Pendo for tracking the behavior on the application. And this application, this part of the code, is responsible for performing some additional actions on the external system when some events happened in our application. So when the customer gets created, or customer logged in, or a Hazelcast cluster was created or deleted, we are recording that for some, dashboarding, fancy views for product managers, and so on and so forth. So this is more or less a very, as you can see, extremely simple thing. So a couple of things that I wanted to prove and show that show value. So one of the things is we get this cluster listener that listens to those cluster events, and it's obviously as a test. And this test, and that's what I was talking about, the unit testing. If you look at this test, apart from a bunch of blocks and some weird code and low-level stuff like event on cluster created, doesn't really tell you whether this application works correctly or not. And that's my problem with the unit testing, that I start to test on a very low level, which is fine, but just that doesn't give me a right overview whether my application was going to start. Because that has nothing to do with this higher level of abstractions of my application, because then I have another test, which is pretty much all together bundled as a Docker container, or with the Docker dependencies that let me know what I'm testing and what is running. So if I, as you can see, I'm running the Spring Boot application with some additional properties. So these are environment variables, actually. And if I run this test, this will pass, obviously, because please pass. I haven't actually tried running that this morning. Okay, so it was waiting for the MySQL to start. So okay, it's run. It's green. But if I remove the environment variables, the test will fail. And that's a good indication for me. Like, what's the contract of the application to start on production? And the question is, do you test for that? Do you have test cases that is very explicit what environment variables you need to set on your production environment? How is your application prepared to run in the production environment? This fails because you couldn't create a bean because yes, there was no secret no secret key provided. Usually it's worked like this, that this environment variable is defined something in the values YAML that goes to the Kubernetes, and you never really test it, or you never really know if it's there. The closer you can get it together, the better. If you have it in a single file that goes together on production and in your application code base and so on, that's good. If you're explicit at some points that you're testing against this, that's good as well, because if you change it in your configuration file, at least your test will fail because it was very explicit that it didn't work. So just unit test is not enough. And then we can play a little bit more. I've said at some point during the presentation that running tests together with Mockito extensions and mocking stuff is as time-consuming as running a Spring Boot application. And just to prove you that it's true, cold start is around 500 milliseconds. There's literally nothing in this test. So it's half a second to run and start with Mockito. So what I'll do is I'll do something like this. I'll remove the Mockito, and we'll start building a Spring test application. So instead of injecting mocks into my class listener, I will outwire it, because that's my service under test. I want this to be initiated. So it's my client listener class. Cluster listener class, yes. And then I have a bunch of mocks that I am running or spying or doing different stuff. This is spying because I need to initialize that with some environment variable. So what can I do instead of mocking? Spring has a very nice thing, a couple of versions ago, that I can do test configuration. So I can prepare a second class in my test, which I'll annotate as a test configuration. And that will act as a test configuration for my test class. That's getting a little bit controversial. Some people say, hey, I don't want to repeat something in my code. On the other hand, I argue that I want my test to be self-contained. If my test fails, I want to find everything that could have potentially made this test fail in the test code or in the code that is directly related to my test. So classes that I am testing. Not that my test failing because somebody else changed something in a totally different way, part of the application, and something stopped working. So I'm a big fan of test configuration classes. So instead of mocking stuff out here, I need to provide dependencies for my classes. So if I now run this test, it's going to fail because I don't have dependencies for my classes. I have to provide them. I can provide them two ways. Easiest one for me is the what I had. I had a this class was my dependency, so I don't need to spy it. I can just build it. From the environment. Environment needs to be something now, or at least protected. And the other thing was the client application that I was using. So that's a fine interface. That's very simple to mock. What I can do is I can do like this. I'll revisit it in a second, but that will make my application start. I don't need it, and I don't need it. That should make my application start. The test will fail, but the application will just start. And so it's kind of a, okay. I can't remove it, I have to, how to wire that. Okay, so now the test failed, but the whole container did, no, the container didn't start. Construct one. Okay. I've defined my classes, but I haven't defined the therapeuts. That's a beauty of live coding. Okay, the test failed, obviously, because it's. Okay, one more thing. I have to refer my test classes. Now it's as complete as it can be. So it's starting. Okay, the test failed due to Mockito style, but as you can see, initializing the cluster by Spring, we have started context, took less than Mockito. It can be really fast. Now you can ask, okay, but this test still doesn't work. How we can make it working? I'm again a big fan, rather than mocking classes, providing fake implementations. I don't know if you heard about or played with fakes. I can provide a fake implementation of the class just for the sake of testing, in a similar way that Mockito does. Because whenever I have Mockito, and I say verify something, or I can do this when something happens, provide the response, I'm faking the implementation. So I can provide a fake implementation of a class. So I can do fake Pendo client implements Pendo client. And this is what I can do here. It's still the same interface. I can use it. I can even return it here, and still my code will be working. So if I run this now, it will get the same exception, but it still doesn't work. But I've changed the implementation completely. So what I can do is I can use it and do something like this. My test was only capturing the information that I was receiving. So I can say we can have this track object, which is a captured object, and when my fake implementation is invoked, I just assign this capture object, and I would like to provide a getter for that because I would like to get this object from my class. And that's my fake implementation. It pretends that it's a implementation of my class. Just think a little bit more. Trying to remove now Mockito completely. I don't need that anymore. I have my fake implementation. And in my fake implementation, I can do get captured object. This one should now go B. No, not yet. Okay, there is some custom. I'll just shortcut that. Not to fiddle with the generic types. Okay, didn't compile. Now the test is green, so I can run all the tests. As you can remember, with Mockito, it was 500 milliseconds, 500 something. Complete string run even faster. So there's no argument that using integration tests by framework make things really, really slow. Other things can also make things really, really slow. And there is a lot about opinions in that case. On the code review, you may get, I don't like this approach, I like different approach. And what I found really effective is that the ultimate truth is in the build time. If the build is faster, the approach is better. Because what we really want is we want faster, reliable builds that are actually testing the code we are providing. Do you have any other questions? I can go like this with examples forever. So. If you don't, I can call it a day. Then thank you very much. I hope you somehow will find it useful. Those presentation and examples are available. This is a really simple project. It's easy to orient when you're a Java developer, so you can figure out how these examples works and how you can play with that. Thank you very much. It's great to be here. It just could have been slightly warmer. Yeah, you are doing the raffle.
Yeah, raffle, but I can use mine too.
Okay, I'll just plug it.
Yeah.
Plug
It's a HDMI.
Yes.
Here we go.
Oh. Okay, just want to see who would like to participate in our raffle. Raffles today, 2 IntelliJ licenses. Anybody? Actually, this is very small. This is so huge. I see. This is kind of strange. Why is it so small? No. Is it small here? It's not that small.
Resolution.
This one, let me, this different resolution in here. Okay, this might be okay. I'm just going to have to, you can see it. Okay, so over there is okay. Okay, so I just know Logan.
Yeah,
right?
I actually don't need it. I already have my
Oh,
own, so you
okay.
can remove me and give someone else a better shot.
Okay, thank you. Claudio? Claudio, right? Okay. Igor, yeah, and then you are Alex. Okay. Let me see. Okay, and who else would like to participate? Tom, you already won in July, so you're not. Yeah, that's right, in July. So I kind of checked to keep track. Iran, would you like? No? Okay. And this gentleman? No, okay. Yeah, and you are with HR, right? Is that right? Yeah, so. So thank you, Ricky. And Che, you already. Okay, Che already. Okay, so just 3, actually, in that case, it makes it, okay, and I tried to ask folks online too, although, let me take a look.
I already turned off. Yeah, I didn't ask.
Oh, you didn't ask. Okay.
Yeah.
Well, I asked to on the YouTube, but nobody responded back
Okay.
during when you were demonstrating. But nobody. Okay. So if that's the case, then we have 3. So, all right. So your chances are very high. Okay. Here we go. Oh, you didn't ask. Okay. Claudio asked you on the YouTube, but nobody responded back. Okay. Wait.
You have the
Because
YouTube.
I'm also have the YouTube on. Okay, Claudio. So, okay. All right, good. Now we have Igor and Alex. Okay. Please stay tuned, on our meetup.com. Then, we'll be announcing it too once we get confirmed. So, yeah. And then if you have any suggestions of speakers, of anything, if you like to present to, please let us know. Let me know. And Che too. Both of us are volunteers. And right now too, in fact, we are in need of volunteers because the rest of the volunteers are not actually doing as much now. I think also because of the, this is like post-pandemic. I think folks are not ready yet or something. So, but we're welcoming anybody who is or are interested in helping too. So please come and talk with me. And yeah, so thank you. All right. So with this kind of is a wrap for today. So thank you again. And we're just going to be, this is, all done. But you're welcome to hang out a little bit. I think it's okay, right? If we kind of chat a little bit. So thanks a lot. Okay. Bye. Yeah. Okay.